This is a single solid bar of steel. No hollow core, no seam, and nothing running through the middle of it. In just a few violent seconds, it will become a hollow pipe, and no drill will ever touch it. So how do you open a hole through the heart of solid steel without cutting into the center at all? To find out, we will follow steel from a roaring furnace all the way to the pipe beneath your street. There are two ways to make a steel pipe, and one of them looks completely impossible. Right now, wherever you happen to be sitting, you are quietly surrounded by them. Steel pipes carry your water, your gas, and the oil that keeps the entire world moving. They hide inside your walls, run beneath the roads, and hold whole skyscrapers standing upright. Yet every single one of them belongs to just two families, welded or seamless. Both begin in the very same place, with raw steel and an enormous amount of heat. Steel itself is mostly iron, blended with just a small whisper of carbon. It arrives at the pipe mill in two shapes, thick round bars or long flat coils. And the very first step for either kind is always to make that steel glow. The furnace drives the steel past 1,200 degrees Celsius until it burns orange. At that temperature, the steel softens, turns a glowing orange, and begins to yield like clay. Solid steel you could stand on all day now bends and flows under gentle pressure. This heat is the whole secret. Cold steel would shatter, but hot steel obeys. Let us start with the easier pipe first, the one made from a flat strip. It begins life as a giant coil of steel, wound as tightly as a roll of ribbon. This strip even has its own name, skelp, and it is about to become a tube. The coil is slowly unwound and fed into a long line of carefully shaped rollers. Roller after roller curls the flat strip, gently lifting both of its edges upward. Bit by bit, the strip closes into a round tube until its two edges finally meet. But merely meeting is not joining. That seam still has to be sealed permanently. This is done with electric resistance welding. There is no flame and no added metal. A powerful electric current is forced straight through the two touching edges of steel. The edges resist that current. Resistance turns into heat, and rollers crush them together. The steel simply fuses to itself, welding the seam using the strip's own melted metal. That weld leaves a raised bead, which a sharp blade shaves away while it is still hot. Cooled and trimmed, the pipe turns smooth, and the seam becomes almost invisible. This is welded pipe, fast, cheap, and produced in mile after endless mile. It carries water and gas through cities and homes all over the planet. Machines can turn this pipe out at tremendous speed, meter after meter, without ever stopping. But a welded pipe has one quiet weakness. That seam is a line, and lines can fail. For the most brutal jobs on Earth, engineers demand a pipe with no seam at all. Think of pipes for deep oil wells, where pressure could split an ordinary tube like paper. There is no drill anywhere long or precise enough to bore a well pipe this way, which leaves an impossible-sounding question hanging in the air. How do you make a long, hollow pipe with no seam and no way to drill it? The answer is one of the most astonishing tricks in the whole of metalworking. And it starts once again with nothing but a plain solid bar of steel. This bar is reheated until it glows a soft white hot and is ready to move. Then it is fed between two heavy rolls, shaped like barrels and set at a slight angle. The rolls grip the glowing bar and spin it fast, while steadily pushing it forward. The steel twists and rotates, squeezed hard from every side, all at the same time. And deep inside that spinning bar, something genuinely strange begins to happen. The rolling stress travels inward and slowly gathers at the exact center of the bar. At the very core, the metal is stretched and pulled apart from the inside out. A small hollow cavity quietly opens along the center line, and no tool ever touches it. This is the payoff we promised. The steel tears itself wide open from its own heart. It is called the Mannesmann effect, named for the brothers who discovered it in the 1880s. They noticed that steel bars, rolled this exact way, kept mysteriously cracking straight down the middle. What first looked like an annoying flaw turned out to be an extraordinary gift. It feels backward. You make a hole by pressing the steel, never by removing any of it. Now that a hole exists, a hard, pointed plug is driven straight into the opening. The spinning steel flows around that plug, which shapes the rough cavity round and true. What emerges is a thick-walled hollow tube, which the mill calls a mother tube. But this shell is still short, heavy, and a long way from being finished. It is threaded onto a long rod, called a mandrel, running right down its center. Then it is rolled again, stretching the tube longer while squeezing its walls much thinner. The mandrel inside controls the bore, the smooth round hole running through the pipe. A stubby glowing shell can stretch into a finished pipe, many times its original length. Reheated one final time, the pipe then passes through a machine called a sizing mill. A tight ring of rollers pinches it down to one exact outer diameter. Sensors measure that diameter constantly, correcting the rollers automatically as the pipe rushes through. Every pipe in the batch comes out matched, down to a fraction of a millimeter. Only now does it finally look like the steel pipe you would actually recognize. But there is still a problem. Fresh from the mill, the pipe is slightly bent. Cooling steel tends to warp, and a crooked pipe is nearly useless in the ground. So it rolls through a straightener, a set of angled wheels that spin and press it. In just seconds, the curve is gone, and the pipe lies perfectly, dead straight. Now this pipe might one day hold gas at crushing pressure, so it has to prove itself. It moves to the single most important test in the entire factory, the pressure test. Both ends are sealed shut, and the pipe is filled completely with plain water. Then that water is pumped up to a savage pressure, far beyond anything the pipe will face. Some line pipe is squeezed past 5,000 pounds of pressure per square inch. Water is used because it barely compresses. If the pipe bursts, it does not violently explode. The pressure is held, while sensitive machines watch for the tiniest drop, the smallest leak. Then scanners sweep the walls with ultrasound, hunting for cracks hidden deep inside the metal. Because in a gas line, one single missed flaw can one day become a fireball. The pipe passes, but now bare steel faces one relentless, patient enemy: rust. Left alone, water and air would slowly eat it back into brown flakes of iron. So many pipes are given a suit of armor, made from a completely different metal. They are dipped into a shimmering bath of molten zinc at around 450 degrees. The zinc bonds tightly to the steel, wrapping the whole pipe in a bright, tough coating. This process is called galvanizing, and the zinc does something genuinely clever. Even if that coating is scratched, the zinc corrodes first, and the steel underneath survives. It acts like a metal bodyguard, sacrificing itself to protect the pipe beneath it. Bigger pipelines get heavy coats of epoxy and plastic to survive decades buried underground. And where two pipes screw together, precise threads are carefully cut into their ends. Finally, the finished pipes are stamped, bundled, and shipped out all across the world. Some are joined into pipelines that stretch on for many thousands of kilometers. They carry oil and gas across deserts, over mountains, and along the floor of the sea. Others become the water mains buried silently beneath every single city street. And the largest steel tubes become the very skeletons of skyscraper and long bridges. They range from tiny tubes to giant lines wide enough to walk straight through. One single family of steel, patiently shaped for 1,000 completely different jobs. Almost everything about modern life quietly depends on these hidden steel arteries. So there are the two paths, one pipe rolled from a flat strip and welded shut. The other pierced clean through a solid bar, with no seam anywhere upon it. And it is that second pipe that holds the secret we began with. Remember the impossible question, a hole through solid steel with nothing at all drilling the center. The answer was never to cut the steel away, it was simply to squeeze it. Spun and crushed between two angled rolls, the metal quietly pulls apart at its core. A cavity born from pure stress, opening in the one place no tool could ever reach. It was discovered entirely by accident, when engineers cursed a crack they could not explain. Today, that very same crack is engineered on purpose, millions upon millions of times a year. From a furnace to a spinning bar, to the pipe that carries a whole city's water. The next time you pass a pipeline, a railing, or a scaffold, try to look a little closer. That humble gray tube may have begun as a solid bar, torn wide open from the inside. No seam, no drill, just heat, pressure, and over a century of one very happy accident. For more than 100 years, this basic recipe has barely changed, because it simply works. Steel goes in glowing and shapeless. It comes out precise, straight, and ready to last for decades. Simple to lay in the ground, anything but simple to actually make.